Hello, fellow Econauts, and welcome back to our show. I'm here with my brother Ben, the Rocketman, and today we are talking about space manufacturing. Hey, Ben, how are you?
I'm not bad. Hey, fellow Econauts.
Okay. Um, Space manufacturing, I think it's very self-explanatory. It's like, you know, building something in space, you know. We talked about that briefly in our episodes when we talked about space mining and also space debris and many other shows that we have done in the past. Maybe you can let us know a little bit about the challenges when we talk about space mining.
I think there's a number of challenges. First of all, a lot of people don't understand the advantages of building something in space. And it's not just building, a some like a wharf where you can build a spaceship in space, and that's space manufacturing, or making things very expensive or luxurious. There's actually a couple of things which would be very advantageous for us on Earth if we would make them in space. Another challenge is that we need a working infrastructure to reach, when you build something, and we're not talking about huge factories or something like that. It might be small 3D printers floating in orbit to get those things back without breaking anything. So I think these are two of the challenges we would face currently.
Yeah, I think building an infrastructure is number one. Would you say it is easier to build a space manufacturing facility on the surface of the moon, for example, or would it be a better option to have like a space station that would, send out drones, getting the resources, like for example, like we said in our space debris episode, maybe using those to actually break them down into raw material and then build something? Or do you think it's better to have like a facility on a surface like the moon?
Yeah, yeah. Um, I think the answer, it's first of all, it's a very interesting question, and I think this is also requires a few steps. Um, First of all, I think in the moment we are more interested in manufacturing things in low gravity environments or microgravity environments. The moon is a celestial body and therefore has a gravity. It's just 20% of Earth gravity, but it might be too strong for some of the things we want to make in microgravity. Um, I wouldn't exclude the moon as a space manufacturing position per se, but I think first things would be actually in orbit. I think that is the first place where we manufacture. You could now argue that with Artemis and a permanent base on the moon, maybe there's something we do there. So yeah, maybe. But I think for commercial applications, orbit would be the way to go. The second point you made,
So sorry if I
hmm?
interrupt. I
Yeah,
mean,
no worries.
obviously, one would not exclude the other, right? I mean,
Yeah, no, of course. No, no, yeah,
I mean,
sure, sure.
I think the wise choice would be to explore both, and then even maybe go and build both at the same
I think
same
it
time.
also it depends also on which frame you put it, right? I personally look at it from a more commercial aspect,
Yeah,
from the private sector. Um, NASA Artemis is initially just, pushing the boundaries further for humanity. And, next thing is building a station on the moon, which will initially be more for research and they might explore things, but they have done that on the ISS as well. Can you then already speak of space manufacturing if you just research the concept of it? I don't know. Like we could split hairs and
exactly. Yeah.
would yeah, right. But from the commercial aspect, I think orbit would be the first thing, first place to go. But to your second point, sending, I don't see space manufacturing initially as collecting something, mine something, be it, debris or other celestial floating things like comets and stuff like that. I think it would be more like we send something up which cannot be made or can be made on Earth, but not in the quality we can. make it in
Or
orbit,
efficiency.
or efficiency. So just to give a few examples, and two of them are coming straight to my head, and I think if you Google them, you can actually find way more. So we have talked about space medicine, and some chemicals you can make better in low or microgravity environments. They are then purer. The crystalline structure of some of those chemicals, they become more, symmetric and whatnot, and therefore they have a better, they have a stronger impact in your body. So again, I'm not a medical professional. I'm not a chemist. Chemist, yeah, chemist. That's the word actually.
That's
So
the,
therefore, I cannot explain. I cannot explain the. Sometimes English is simple. I cannot explain the details. But from my understanding, symmetry, for example, is very important. Crystalline structures are very important in order to get a certain reaction, or to target a certain cell or whatnot, for painkillers, for example. Another very important thing is that you can actually, or actually, I have two more examples, but one is glass fiber cables. You can extrude those way better in microgravity, and therefore you get longer glass fibers with a purer structure, and therefore they are more efficient. They don't lose as much energy. It's called attenuation when you use these glass fiber cables, and therefore they can transmit the data way better.
yes.
You can, and another thing is 3D printing. A few things, on Earth, if you have a 3D printer, you have these horizontally aligned print bed, and then you have to put everything on that, and you have to realign this bed very often. And there's a lot of applications where you can 3D print, because it's sort of you can print and it extrudes, and because there's no other gravity sort of acting on it, you can actually achieve way better forms
Yeah,
and better
because it's
structures.
floating
And
around, right? Instead of
yeah,
having the gravity pressing it down.
yeah, exactly. And this can actually it can be beneficial for the structure. For other applications, it might be beneficial to have actually the gravity compressing it a little bit. But in either way, sometimes you might want to do this. And these are, I think, very good examples for space manufacturing. If you extend the topic a little bit as well, you could also say space manufacturing is any manufacturing for space parts. So
Right.
you could also argue some manufacturing might happen on Earth. I don't know, be it screws or whatnot. Just you laugh, but some of those have very, very precise tolerances and materials which have to interact with all the other materials, so that you don't get any interaction once you're in microgravity. So it's actually quite important to use the right parts, and you know
Right. I also think that if we look into space manufacturing, it has of course also the benefit of, if we can do that in orbit and on the moon, it is, and we have built something there. So much easier to build that also on the Mars, for example, right? Which is where I see a huge benefit if we can build something on the moon and see that this is actually working. Building it on Mars, where it is so much harder to actually send something if there's something
yeah,
broken. You need to have the
yeah,
material
100%.
available,
Yeah,
and you need to
100%. Yeah.
have proper manufacturing available to secure that you can be self-sufficient, right?
Yeah, 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 no, 100%. And weirdly enough, although it's easier to get to the moon, landing on Mars is easier than landing on the moon, because Mars has an atmosphere, which the moon does not have, and therefore, there's some advantageous or boundary conditions to actually get there. It's just the distance, which makes it so hard to send, resupply. And you're absolutely right. That's definitely also covered within space manufacturing, making things without having everything available. And this goes on Earth, you don't think of it, but even water. Water is very important. You
Yes.
need to be able to extract water, and it might not, if it's there in ice form, then you're very lucky. You just have to melt it. But if it's just if you only find hydroxyls, for example, in the regolith of that's the soil on the surface of a celestial body, you might need chemical processes to actually extract it from that, and they might be quite high in energy requirements. And then how do you get the energy? And so you need to understand everything of it. And if you really extend it to that, how to build things on a surface, on a celestial body, then space farming and space agriculture somewhat becomes also space manufacturing, because now you have to
Right.
repurpose the soil, the regolith, to actually grow something. So I think it's a very intertwined topic. Also, given that we learn so much from it. Not only do we learn the composition of other planets and so on, which helps on the research side to understand the universe better and how planets are formed and so on, but also I think we can learn a lot, even on Earth, to be more efficient in terms of making something.
Absolutely. I think that everything that we can do in space, we can do on Earth as well. I mean, if we
Yeah, not everything, but we
well,
don't have
well,
microgravity. But yeah,
but you
yeah.
see where I'm
Yeah,
going
I
with
get
that,
your
right?
point.
If
Yeah,
we increase the difficulty level by building something on the moon, it, like you already said, if it's easier to land on Mars, then it should be easier also to build something on Mars if we know how to build it on the moon. And
yeah,
also that means if we can build it on the moon, we might be able to improve certain facilities here on Earth, right?
yeah,
So I think that the underlying message that we have in our show, it's always to look beyond, right? To see how can we actually push our boundaries more and more,
yeah.
and how much it actually benefit us to explore space.
Yeah, I think another really big aspect is there's a lot of talk about circular economy, meaning you want to recycle waste, so that
Yes,
waste is not really waste but a resource. And I think this is specifically true in space, because in space, yeah, if you have to bring the mass up there in the first place, you might want to use everything as
absolutely.
often as possible. So if you have to put some energy in from solar panels in space, then you do it because you need to. You can't afford to just expel the mass you have into space. You need to reuse it. And if we go, now it comes a bit of a sci-fi part. I think Star Trek works in a very similar way, where they, whenever they have waste, they make, I think it's dark antimatter or something. They make or matter. They make matter out of
They
it,
basically
and then
they recycle items into energy, and then from
yeah,
energy
yeah,
back into.
this way, yeah, exactly. So, but but exactly that's more or less the final goal, right? If we could do that, and obviously, let's say we could do that, then we could do that on Earth as well. You don't need
Absolutely.
any waste anymore. You make just energy out of it, and then you can make anything else out of it. So,
Yeah.
but obviously, that's the sci-fi
That's
position part of it.
way in the future. Now we have to do
Yeah,
step number one is
yeah. Step
getting
number
to the
one.
moon. That's already very exciting. Building
Well, we
is
have been on the moon
yes, but
again,
coming
again.
back to the moon with the goal of having a permanent base on the moon. I think that
Yeah,
this is amazing, and this is like incredible to witness that. I mean, that's a huge step for us as humans to be
it's a
able to
small step for the astronaut, but a huge step for
for
humanity.
humanity. Exactly. All right. Well, thank you so much for your time as always, and I enjoyed talking to you about space manufacturing, and I hope
Yeah.
you enjoyed our show as well. If you do, don't forget to leave a like, subscribe if you haven't already, and we like to hear from you, so don't forget leaving a comment. All right. Thank you so much for listening to us, and have a good day. Bye bye.
Bye.